Hello and welcome to the MecSoft demonstration series, where you can see live demonstrations for real users and real-world applications. For more information about our products or to schedule your own live demonstration, just give us a call or visit us at www.mecsoft.com. Without further delay, we invite you to sit back and enjoy the demonstration.
So what we're going to be demoing today is going to be our flagship standalone CAM product called VisualCAD CAM. Version 2017 is our latest version release. So you have a shortcut on your taskbar on your desktop. You can click on it to launch the application. So VisualCAD CAM is a standalone CAM application which basically allows you to read files from a variety of different CAD systems. So if you go up to the Home tab in the CAD interface and click on Open, this gives you access to file translators. You can open files from different CAD systems out there. So you can bring in 2D drawings like DXF, DWG. If you have a solid model, you can do IGESTEP, STL, Parasolids. So all of these file formats are supported, and you can import them in from your CAD system that you're working on. Okay. Now, since you talked about Onshape, since you are currently using Onshape, we also have a plugin connector for Onshape that will allow you to import files directly from Onshape. So if you notice the Home tab, I have a plugin called VisualIMPORT for Onshape also installed in here. So I just go up to the menu and then choose Import from Onshape. Okay. So when I pick Import from Onshape, initially you will have the option to sign into your Onshape account by clicking on sign in, and it'll ask you for an authentication code, and once you put that authentication code in here, it'll go ahead and log into your account and display all of the documents that you have under your account. So as you see here, I have several documents right in here, so I can click on, you can see the documents I got right there, so I can select the part I would like to wish to load. Okay. So now if I want to bring in this part, I just select the part and then I hit load. Now you have settings where you can choose whether you want to open the part as a solid surface geometry or as a mesh geometry. Those settings are available. Now here is a pretty prismatic part, as you can see, which is basically created by drawing a bunch of circles, arcs, and then extruding them to a 3D model. You see that in here, sir?
I understand that. Yep.
Okay.
Yep.
Now, since I chose to import as a solid surface geometry, like a parasolid import, it automatically brings it in. It also shows the current model units is in millimeters. I can go over to analyze and click on part information. It gives me the dimensions in millimeters, but I may want to work in inches, so I can just click on units, and I'm being prompted, do I want to switch to units? I pick yes, and the model is automatically switched to inches. Okay. Now if I go back and check the part units, it gives me the length, width, and the height, as you notice it right in here. So you got the part imported directly from Onshape using the VisualIMPORT for Onshape. We would call it the app or the connector plugin for it. Now once you got the part imported, you're ready to program your toolpaths in here. So the first step is you go over to the machining browser. If the machining browser is not appearing in the viewport, you just go up to the VisualCAM menu and you click on Mill, and that automatically displays the machining browser.
Okay.
Now the top half is the machining browser, and then the bottom half of the screen is the machining objects browser. So the objects browser allows you to define tools, or you can bring tools from your library in if you already have a tool library defined. So you can create tools of type ball mill, flat mill, corner radius, V-mill, chamfer, taper. You have all of these tool types that you can create. You can also create user-defined tools, and of course your drilling tools. Now for each of these tools that you define, you can also establish your feeds and speeds. We also have a built-in feeds and speeds table that will help you compute the feeds and speed based on the material you're working with.
Okay.
And once you have this information in, you can save them to a library in here. So that's what I got, a library of tools loaded. Now the first step is to define the machining process. For 2 and 3 axis, it's automatically set to 3 axis, which is available right from our standard configuration. You can also program 4 and 5 axis toolpath depending on the type of machine tool you're working with in other configurations. Now the next step is to select the post processor. This would be the type of machine tool you're going to be working with. Do you know what type of CNC equipment you're going to be working with, sir?
I'm going to be working with several different types. I work with a Fanuc Zero. I work with a Centroid. I work with what was it called? Mach 3. That's
Okay.
that retrofit computer, and a Haas.
Okay.
Those are the 4 basic ones.
Okay,
So
and are
basically,
they all...
I'm using a FANUC controller, a FANUC post for all of them. What I'm currently doing, and then I make alterations for the little things.
Okay. As you notice here, our library of posts, entire library is made available to our users. So we currently have over 225 different post processors in here. So if you take any one of these posts in here, I could say I want to use a FANUC OM, and we have a built-in post generator where you can edit and you can modify to create variations of the same FANUC posts.
Okay.
Now this comes included with the product, so also we will help you make any edits or modifications to the post processor as well. As part of support, we do that. Now we have posts for FANUC, we have posts for Haas, we have posts for Mach 3, so you name it, we pretty much have most of these post processors that you listed out, and we can just select them.
Now I've got one question about that. Is the post simple? It looks like I can edit the post as I see I need to. Is that correct? I don't have to send it back to you.
That is correct.
Okay.
If you need help
Okay.
in editing the post, we are always available to help you out as well.
Okay. Got it.
And you can set your output extension. It could be NC, .tab, .cnc, whatever is the preferred extension. Most machines do read .nc file, so you pick .nc.
Okay.
All right, so you got the part in here. Now you want to program toolpaths from it. So you just go ahead and, you got the part, you got this, post defined. The next step is to define your workpiece, your stock material. So the standard configuration allows you to define your stock as a box or a cylinder. So I could go with a box stock, and you'll notice that this automatically computes the length, width, and the height of your stock material.
Yes.
So you can change the parameters if you need to. You could say I want to go with a 3x3, and then maybe a 1/2 inch thick block. You set those parameters, pick OK to accept it. Your stock is now created, and it's displayed right on your graphic screen. You want to center it, so you do align stock. I can have it centered in the Z. I can put it to the top, center, or bottom. So if you want to have it flush to the bottom, you can pick bottom and have it centered in X and Y, and then you pick OK to accept it.
Okay.
So the stock is now centered in X and Y, and also flush to the bottom of the part. So you can face off the material off the top if you need to, or you can have it flush to the top and still work with it just a 1/2 inch plate.
Okay.
So
Now I
next
understand
step,
all that. Yep.
you get your in a step to assign your 0, 0, 0. So you can go to set world coordinates. You can pick set to stock. If you want to do higher Z southwest corner, you can do higher Z southwest. It'll automatically set your origin to the top and then the southwest corner, as you notice it right on the top of your screen.
Okay.
Now, we have some pretty nice drawing tools in here as well. So if you want to go ahead and add a facing operation, you want to face the entire stock blank, you can add a facing operation. You can create some sketch geometries in here as well. You can use the drawing tools in here to create a rectangular sketch. I could say I want to throw in a rectangle in here. I can snap to my grid, and I could just throw in a rectangle like that. So we have 2D drawing tools in here which you can take advantage of for creating boundaries for machining. You can also extract curves from the face of the part like a sketch. You can do flat area and then just pick that face. It'll automatically create a curve boundary around the part for you. So you can use those for creating curve boundaries if you need to. So we got this everything set up in here. We are now ready to program some toolpaths. So first step is to create a machining operation. So under 2 axes, you'll have access to roughing, facing, pocketing, profiling, V-carve roughing, V-carving, engraving, slotting, chamfering, hole pocketing, hole profiling, thread milling, and T-slot machining with our standard and expert configurations. If you go with the Pro, you will also have access to 2-axis remachining or rest machining, which is offered in our Pro configuration. Now the standard also offers you 3D toolpath methods where you can do 3-axis roughing, you can do parallel, horizontal finishing, radial, and spiral. Now all of the other methods that you're seeing here are part of the advanced 3-axis package, which is included in our Pro configuration. Now to program this part, since this is prismatic, there's no drafts or tapers, you could program them using a 2-axis operation. So first step is to do a facing. I could choose 2-axis and facing, and now able to pick or select geometries to face. I could choose select curve edge regions. I could just go pick the rectangular geometry I created in here. Now I specify a tool for it. I could use a face mill if I'd like to. Specify the parameters. I could choose load from tool. So the feeds and speeds are loaded from the tool. Establish your clearance plane, which is your safety plane for all your transfer motions. Specify the parameters for roughing. You could choose your cut pattern, whether you want to go linear or offset cut pattern. You can choose your step over in here. In the cut levels, you can graphically pick the depth. So I could choose, I want to go from this point right here and down to the top face of the part. So it knows what the depth is. I could just do it in one pass. I could specify entry and exit if I'd like to, and then pick generate. So a facing toolpath is now created.
Okay.
Now I switch to my Simulate tab. I can select the machining operation and click the play button, and that gives us a simulation of the facing operation.
Okay.
Now you're through with the facing operation. The next step is you want to go ahead and pocket these holes in here. Now you could do 2-axis machining, and you could do pocketing. And you just go pick the features that you'd like to pocket. I can either pick a surface edge or I can pick a circle since I extracted the features from the part. So I'm just going to go and select these features right in here. Make a selection for the tool. I'm going to go with a 1/4" end mill. Set feeds and speeds and clearance, very similar to what we did. And I can specify some stock to leave so we could go back and do a finishing cut, step over, cut levels. I can actually pick the depth in here. I can choose the top and then I can go pick the floor. And now I can specify to cut it in multiple steps. If you wanted to go slightly past it, you can change the depth in here. I can change it to 400 thousandths and depth per cut, specify all the parameters, generate. So we got a pocket toolpath. Now you can even work directly with 2D drawings. You really don't need to even bring in a 3D model, but since you're going to be using Onshape for all your CAD design, you're building it as a part in a studio, in a part studio, right?
Okay. Good.
So now I can go ahead and pocket these holes in here. So if you take a look at the circle, you can also find out what the diameter is. Analyze arc diameter. It tells you that they're, the ones that you selected in here. You can just grab the circle and do an arc diameter. It'll tell you what the diameter is, and then you can go ahead and program a toolpath. So now I could say I want to do a hole pocket. So go to 2-axis, and I could do a hole pocketing as opposed to just a standard pocketing operation, and just go pick those holes in here. So this is how this is a conventional way of programming where you pick features or geometries that you'd like to program. Now you specify a tool for it. You specify the properties, the cutting parameters, and so you just want to do a cleanup pass at the bottom of the hole, and then you specify your helix parameters in here. So you can do a helical, the helix diameter.
Yeah.
And you can specify the helix pitch in here. And if your controller can do a helical interpolations, GO2 or GO3 with X, Y, Z, I, and J, we could do that as well. And here I just put in my depth in here, which is 0.4. And you'll notice that the toolpath, what it creates a cleanup pass at the bottom of the hole right there. So it's doing a helical interpolation. So it's doing a helical cut pattern.
Okay.
And finally, you want to do a profile cut. I could do 2D profiling. And just go grab this face edge. I can select a curve, or I can pick a edge from the model. I can use the same cutter, or I can go back to a 1/2" end mill, a larger cutter. Specify the properties. You can choose which side to place the cutter automatically determine using 3D model. Cut levels. You can specify the total depth, and you can specify your depth per cut. You can set your entry and exit parameters. I'm also going to put in an overlap distance of 100 thousandths in here. Apply these for each cut level and then generate. So we have a profile cut with an overlap distance set.
Okay, I see that. Now, can you also create a ramp on that, like a 3-degree ramp or whatever?
Absolutely. In the profile operation, you have choices for entry and exit. You can do lines and arcs, or you can ramp along the path. Even with the lines and arcs, you can give it a ramp height in here. If you wanted to do a linear, you can specify and give it a height of 100 thousandths. So that'll ramp away from the part.
Okay, I see it now. Yep.
Now if you want to do a long path ramp, you can do a long path ramp as well, which will ramp along the path of the curve, where you can specify the ramp height and the angle for it, and that'll ramp along the path. So it'll be on the path of the curve itself. It'll ramp along the path for you.
Okay. Okay.
And you can always
Now, how
slow
about-
down your simulation speeds as you need to.
Okay, I figured there was a way to do that. Okay. Now, a part like this, I'm going to ask a question, or maybe I'm getting ahead of myself a little bit, but how about I've got one guy that I program for. He would insist that I would do those 5 holes. We're going to say those are, I don't know what, quarter-inch holes or whatever they are. And he would want those 5 holes drilled, and then the center of the bigger holes also drilled, then everything finished. This is the way he likes to do business.
Okay. We could do that. We could select all the holes and then just do a drilling operation as the first, like a spot drill. So you can go to hole machining, you pick drilling, and you just go ahead and say select holes on this face. And now you go grab a drill bit, maybe a 1/4 inch or an 1/8 inch drill bit, and you want to spot drill down to maybe like 25,000 deep, or you know, or maybe the full depth in here, 0.4. Since I chose a 1/4 inch drill bit, that should work for all the holes. And I can go add tip to drill depth. It'll clear it based on the taper of the tool that you define. Then you can sort them, generate. So that's going to give me a standard drill operation. So that could be my very first operation. After the facing, I could be doing a drill operation.
Okay.
I could change this from a standard drill to a peg drill if needed.
Okay. And it doesn't automatically pick the drill by looking at the geometry. I, as the operator, have to pick the drill size. Is that correct?
You would basically specify the the tool size. Now what we also do is feature detection and machining. That is the next thing I'm going to demo to you, where it'll identify all the hole sizes and everything, and based on features, and then you can choose operation and the tool to machine it. So in this case we are manually programming it, which is like a conventional way of doing it.
Okay.
Any questions on this so far?
No, I'm following along good.
So then we got those pockets. After the drill completed, you're pocketing them out. You're going back and hole pocketing the remaining holes. And finally you're profiling it out.
Very good. Okay.
Now you got to do is just hit the save button in here. It'll ask you where do you want to save it, and I can choose a folder on my computer. I can put it on my desktop, save it right in here.
Okay. Good.
You can also take a look at your estimated time. Information will tell you how long it's going to take to cut it based on the parameters that you put in for your feeds and speeds in the tool.
Okay.
And then you're ready to post it out. Right click and post. Choose a destination folder. Your posted code calls out your tool numbers for each operation. Outputs your drill cycles.
Okay.
And each of your operations.
There's a quick question. How does this is a panic post? Where do I define initial height or R plane for the drill cycles?
That's done in the so the R plane is it's using a G81 drill cycle, as you see right here. So the R plane is your approach plane. If you go into your drill operation, under cut parameters, you have your R value. This is where it pulls in from. It's 100 thousandths above the top of the hole.
Okay.
So it does a G81, and then the R value is determined based on the height that you put in.
Okay. So it doesn't produce a G99 or a G98 then?
That's something we can add it to the post, whether you want to do a G99 or a G98.
Okay. Gotcha. Okay, I understand now. I thought maybe there was a button that just, I could flip right there, but okay.
We would have to set that up in the post processor.
Okay.
So this is how you typically program if you're going to be starting out with a 2D drawing or even a solid surface model by selecting, picking curves and programming it, right? Now, the other way to program this would be, now let's say we go back and re-import the model. So I'm going to save this out. I'll create a new part, and I'll just go back and re-import the same part in here. So I'll do an import from Onshape. So this is going to go through the process of, loading the part from Onshape, right? So it's going to go ahead and, locate the parts that you designed, whatever changes you done to the design, it'll update it in the list, and now you can go back and pick the parts. I'm going to use the same part in here. I'll pick load. So the part is now being loaded. I'll switch the units to inches. Okay, now we got the part loaded in here. Now we want to go through the same process. Define your workpiece, define your stock. So here I could say I want to do a box stock, the same parameters. I can set my 0 to, I'll put it to the top center in here. I'll put the 0 right to the top and center. Okay? So the first step I'm going to do here is, rather than having to pick the features, we have a tab called features, and we can identify features. I'm going to say create machining features, and all I'm going to do is pick this face and right click. So in this process it identifies what the features are. You have a planar face, you have these hole features in here. You can see that there's different sizes of hole features. It's identifying those 5, and this one, and finally it creates these arcs as also large features as well. So now what we want to do is we just want to program each of these. So I can select this, right click, and say I want to do a facing operation. Now all the information is in here. All I'm going to do is pick a tool, and I can choose my cut parameters, generate. So I have a facing toolpath program. So if I want to change the cut pattern from offset to a linear, I can just change it. So this is feature detection and machining.
Okay.
Now you said you want to do a spot drill in here, so I can select these 2 features, right click, I can go over here and I can do a drilling operation, or I can right click and choose right click and do a drill operation in here. So you notice that the whole cross section is automatically appearing here. I can go back and add a new feature to it, add this feature as well. So I got this and this, both the features selected. Now I grab a tool for it, and you'll notice that the parameters are already set. I didn't have to go ahead and enter in the drill depth. I can say add tooltip to drill depth. I can sort them, generate the toolpath. So I didn't have to manually pick any of the features. Now the next step is to program these same holes again. So select the hole features, right click, and I have these different operations. I could do a hole profile, grab a tool, a 1/4 inch tool, set the parameters. You can set the other additional parameters in here, your helix parameter in here, generate. So that'll create a helical path cut pattern. So if you have a solid model, a prismatic part, you can do hole feature detection, right click, and you don't even have to go through the process of entering any of these parameters in here. So I can choose a hole pocketing, grab a tool, you got all the parameters in here set. You can specify number of levels for finishing. You can control the parameters like your entry and exit parameters. So all I'm doing is fine-tuning some of my parameters in here. I'm not having to go ahead and modify the depth. Everything is pulled in, the whole diameter is pulled in. So I'm just creating a toolpath.
Okay.
Now if I'd like to change the tool in here, it's pretty straightforward. Just grab a tool, drag and drop it on top of the operation, right click and regenerate. And you see that the toolpaths are automatically computed.
Okay, good. That's nice.
And then finally I want to do a profile cut around it. So I just go back to features, grab this planar face, right click, profiling. And now I have this face selected. I'm going to grab the same 1/2 inch cutter, and you can see that all the parameters are set, the direction to be cutting, and all I'm going to do is put in my total depth in here, and I'm going to say finish depth. I want to go 100 thousandths per pass, and we can do the same type of entry and exits we did earlier, and you can specify an overlap distance in here. You can go along the path, and you can specify the parameters. So you have a finishing cut.
Yes.
So this is how we can do feature detection and machining.
Good.
So there are
Like
several
that.
different ways how we can program it. So
Now,
this is
when-
our standalone system, how you can actually, bring in your designs from different CAD systems and machine it. And all we looked at was 2D milling or 2.5D milling. And I can also demo you 3-axis as well.
Okay. Does the system do simple 3-axis? Or is that an add-on?
Well, it does a lot of 3D milling operations in here. So, let me go ahead and pull in a part in
Okay.
here, and we'll program some 3-axis toolpaths as well.
Well,
Now I
before
can-
you switch, can I
Sure.
ask a question?
Go ahead, sir.
Over in the left-hand side, you created a machine. I'm going to call it a tree for lack of knowing what your terminology is, where it center drills and drills and grabs end mills, and then it cuts that part. Is there a way to use all those definitions, tool definitions and cut definitions, save them, and then the next time I get a similar part, I can go get that tree that had the center drill, end mill, all loaded, and just substitute the new parts or the new features
Absolutely,
into
yes.
that template?
We call this your machining job and then the machining operations. Now the entire programming workflow can be saved to what is called a knowledge base. So you go over here to knowledge base and you have an option to either load or save. So you can save all the operations that you programmed to a knowledge base. So when you're working with family of parts or parts that are similar, all you got to do is load the knowledge base and then associate the geometries to it. Now we can also go one step further beyond this. If you have geometries of certain type, certain like curves in certain layers or certain colors, you can even automate the process of selecting those geometries so you don't have to manually go and pick it.
Okay.
So this is a very
Okay.
nice feature which helps you, the programmer, be more productive and reduces the amount of time to spend and go back and repeating the same workflow over and over again.
Okay. I think I understand it perfectly, that if it sees the whole diameter of, if we were working in metric, say 10.25, it would know it was a hole for a 12 millimeter tab.
Right. You could
And
specify
then
it.
it would go get the correct two holes.
You got to manually make the tool selection, or unless it loads the tool, whatever you have right in here. But then we can say select the geometries based on, automatically. So this could be a spot drill operation for, holes that are, 1/4 inch all the way up to maybe, 3/16 holes, right? So you can select holes of a certain size automatically and then, apply the toolpath rather than having to go and, individually pick each of those holes.
Okay. I got you. Every system is a little bit different on how they do that, and that's why I'm asking that question, is I wanted to see how automated it would actually be.
Yes, like I mentioned here, we can save this workflow to a knowledge base, and also we can load a knowledge base under this tab called K-Bases, and we can assign rules to it to select. Now I'm going to show you how that works. I'll take the example that we had just programmed a short while ago, right? So these are the operations in here, and I'm going to save this to a knowledge base, and I'll put it right on my desktop as well. Okay?
Okay.
And I'm going to go ahead and pull this knowledge base in here from my desktop, and then we'll go ahead and show you how you can actually load this knowledge base. And I'm going to say no when prompted for the rules. Now if you click on each of these operations in here, there's a feature called selection rules. So I can go into the standard drill, double click on it, and I can set filters for it. So when the knowledge base is loaded, automatically select, I could say, arcs and circles of a certain diameter range.
Okay. Gotcha. Yep.
So I could say pick circles of maximum diameter maybe 2 inches. Now, if I just simply drop this operation in here, when I load the knowledge base, you will notice that it'll automatically pick those circles for me. I don't even need to go through the process of assigning it. Also, you can specify rules so that you can select by them layers. So you can have them in different layers. You can automatically pick from layer, or you can even apply a color filter to select geometries of a certain color automatically.
Okay.
So you could have holes. You can do a combination. You can say, I want to pick holes that are of diameter a certain range in here. So you can say, put in diameter as up to 2 inches right here.
Yes.
I've applied the rule. If you go back in here, you can see it's set to 2. Now if I actually drop this in here, it should automatically be selecting them. You see that? All the holes are selected. I didn't even have to go through the process of repicking it. Now all I got to do is right click and regenerate.
Very good.
That's how powerful it is. So when you load the knowledge base, now if I just have one operation in here, I'm going to just clear these out. I'll also delete these. So this is like considering that you brought in a brand new part in here. I'll go ahead and save this to a knowledge base. I'll call it with rules. So now if I go ahead and just say load my knowledge base, and I'm going to grab this one which has the rules on it. Now the operation is loaded. I just had one operation saved to a knowledge base, but you can see that when you click on it, it automatically has all the holes selected. So I didn't have to go through the process of selecting any of the holes because the knowledge base has that rules specified to automatically pick holes of a certain range.
Okay. That's
So
a nice feature. I like that.
So there's a lot of pretty neat features that are built into it, and you can take advantage of those.